Assalamu alaikum again. So today again we are going to discuss chapter 10 about carboxylic acid and their reactions. The first thing, as I said, is the nomenclature. And for the nomenclature of carboxylic acid, there are two parts. For the long chain carboxylic acid, we need to replace the final E with oic acid. And then always carboxylic acid must take number 1, and then we number the chain accordingly. In case for the presence of more other functional groups such as ketone, aldehyde, or alcohol, or alkene, or any other functional groups, the carboxylic acid has the priority. Therefore, the other functional groups, as we said in the slides, there will be like substituents to this parent name. The other part of the nomenclature of carboxylic acid, which is when the carboxylic acid functionality directly attached to the cyclic system. In this case, we need to give the parent name of the cyclic system, like cyclohexane, for example. If we have cyclohexane attached to carboxylic acid, in this case here, we have to name this parent name, which is simply cyclohexane, and then we add after that carboxylic acid for simply this functionality. So this is simply the two parts for the nomenclature of the carboxylic acids. I think it's very straightforward. The nomenclature shouldn't be any problem, and the examples, you have it there, almost like comprehensive examples for all aspects of carboxylic acids. Now, the other section here, which we are going now to talk about, which is the synthesis of carboxylic acid. But before talking about it, I just would like to ask, is there any question about nomenclature, please? The nomenclature or IPAC nomenclature rules for carboxylic acid. Is there any question about it? All right, perfect. So the next section here, which is the synthesis. What are the synthetic method or the synthetic preparation method to get the carboxylic acid? The first method, which we have discussed before in chapter 5, which is the side chain oxidation of alkyl benzene. Whenever we have R group here, when we use KMnO4 in presence of water, we are going to oxidize this alkyl group, and then we are going to get a carboxylic acid. The most important thing here, the carbon directly attached to the benzene system must be primary or secondary. Remember, tertiary carbon does not work. Remember also that this reaction works for aromatic system, not aliphatic system. In other words, if you apply, or if you try to apply the same idea, for example, if you have here CH3, if you have aliphatic system in here, if you have cyclohexane or methyl cyclohexane, you try to oxidize it in presence of water, this reaction will never succeed. So this reaction is specific for aromatic compound. The other reaction, which we also discussed in previous chapters, which is oxidation. We can also prepare carboxylic acid by oxidation of two other functional groups, such as primary alcohol or aldehydes. So the oxidation here, using, of course, strong oxidizing agents such as the Jones oxidation agent, we can oxidize primary alcohol, for example, RCH2, OH, presence of CrO3H+. We can simply convert it into the corresponding carboxylic acid. Remember that we need here for the oxidation of either primary alcohol or the aldehyde, we need a strong oxidizing agent. It's not the mild oxidizing agent. PCC cannot convert these two functional groups into carboxylic acid. The third method, which is by hydrolysis of nitriles. Nitriles, which are CN here, in principle, whenever we have nitrile or C triple bond N attached to R, we call it nitrile. So in order to get the nitrile, we need alkyl halide, for example RCl. We need to make a nucleophilic substitution via SN2 reaction. We can convert it into a nitrile, and then this nitrile can be hydrolyzed by first sodium hydroxide or heating up with sodium hydroxide. Secondly, with acidification, we can get RCOOH. So this is the second method, or the third method for the preparation of carboxylic acid. As you can see, this method is as an example for nucleophilic substitution. We can introduce first the nitrile, secondly we can simply hydrolyze it. Is there any questions so far? Any question? All right. Now, for the nucleophilic substitution reactions, let's start with reactions of carboxylic acid. As you can see here, the carboxylic acid can be, as we also have explained before, carboxylic acid can be fully reduced by the strong or powerful reducing agent, which is the lithium aluminum hydride. We can convert it into primary alcohol by lithium aluminum hydride. In other words, this is the direction of the reaction for oxidation of primary alcohol to carboxylic acid. We can also simply just make it in the same scheme like here. If we have carboxylic acid, we would like to turn it back to the primary alcohol. What we need is the reducing strong or powerful reducing agent, which is lithium aluminum hydride first. Second, acidification. We can simply convert carboxylic acid into the corresponding primary alcohol. For the reactions of carboxylic acid to carboxylic acid derivatives, we can always convert carboxylic acid into the carboxylic acid derivatives by choosing simply the right reagent. For example, in this case here, as you can see in this slide, carboxylic acid first, we can convert carboxylic acid to the corresponding acid halide or acid chloride specifically, for example, by reacting with thionyl chloride. By reacting with thionyl chloride, we can convert it into what we call it acid chloride, which is the first carboxylic acid derivatives. If we heat up any carboxylic acid, we can convert this into the acid anhydride. So this is acid anhydride by heating up this carboxylic acid salt. It's as if we are just removing a water of two molecules of the same carboxylic acid. Third reaction, if we allow the carboxylic acid to react with alcohol, any alcohol, either if R is the same or different, in presence of H+, this is called Fischer esterification. What we are going to get, the ester. And finally, by heating up carboxylic acid with amine or ammonia, primary or secondary amine or ammonia, for example, ammonia with heat, we are going to get the corresponding amine. So in principle, carboxylic acid can be converted into all carboxylic acid derivatives. So this is the first reaction of carboxylic acid. Now, the second, these are actually, in this slide, the second slide is simply examples of these reactions. Now, for the reactions of carboxylic acid derivatives, all carboxylic acid derivatives can be hydrolyzed back to their corresponding carboxylic acid. So always remember that carboxylic acid can be converted to derivative, and derivative can be converted into carboxylic acid back. So in other words, let's just summarize it like this way. Let's assume that carboxylic acid derivative, we call it RC-OY, where Y here is any electronegative atom. For example, such as halogen, chlorine, nitrogen, or oxygen. And we have the carboxylic acid. So in the previous slide, we have discussed how to convert carboxylic acid into the carboxylic acid derivative. For each reaction, we need to check carefully what's the reagent needed to do so. Now, in principle, all derivatives here can be converted or can be hydrolyzed back. All carboxylic acid derivatives can be hydrolyzed to carboxylic acid. And now the hydrolysis here, or the reagent, or the condition for the hydrolysis, it's always water. Water in presence of H+. But since the carboxylic acid derivatives, they have different strength towards reactivities, some, or the strong, or the active carboxylic acid derivatives will only need water, while the very low reactive carboxylic acid derivatives, such as amides, they will need definitely harsher conditions or more hard conditions, such as water in presence of H+ and heat. So the reagent to do so, either water for the reactive one, just addition of water, like for the acid chloride, or water in presence of H+, or water in presence of H+ and heat. So all of these are or can be the reaction conditions for the hydrolysis of the carboxylic acid derivatives, as you have seen in the next slide, in the slide where you have it. So this is simply the case here. Carboxylic acid derivatives can be converted or can be hydrolyzed to their corresponding carboxylic acid by these conditions. Any questions so far? Is there any question? All right. Now, for the conversion of acid derivatives to each other, we can simply, as you have it in the slide, carboxylic acid derivatives can be converted into each other by certain reaction, but certain rule first. Now, first of all, let's simply write all them, let's order them by reactivity. As we explained in the slide, the acid halides, for example, acid chloride, is the most reactive one, then the anhydride, then the ester, then the amide. So this is the most reactive toward nucleophilic addition elimination reactions, and this is the least reactive one. So the rule here is very simple here. All reactive carboxylic acid derivatives can be converted to any less reactive one. In other words, acid halide can be converted to the anhydride, can be converted to the ester, can be converted to the amide, because all of these are less reactive than the acid halide, but vice versa is not true. In this case here, if we want to start from the anhydride can be converted to the ester, can be converted to the amide. If we want to start from the ester can only be converted to the amide. So as you can see, the amide can be prepared by all of these functional groups, but it cannot prepare other functional groups. So all of these functional groups can prepare the amide, but not vice versa. I think this is it's a very summarized way, but it's at the same time gives you a very specific, precise perspective how the reaction or the conversion between carboxylic acid derivatives undergo. Is there any question about this? Because that's actually the last aspect of the chapter is the conversion of carboxylic acid derivatives to each other. Is there any question about it? Is there any question about the last slide, the conversion of carboxylic acid derivatives to each other? All right, it's a very summarized, as you can see, very summarized presentation about the carboxylic acid and carboxylic acid derivatives. With that, if there is no further question, I would like to thank you very much for attending the lecture, and I wish you Ramadan Kareem, and inshallah next week happy Eid. كل عام وأنتم بألف خير ونراكم على خير إن شاء الله. Thank you.